Okay, welcome back to Ask an Engineer. Thank you so much for joining us. My name is Andrew Garchik. I'm an application engineer for DesignPoint. I manage our 3D printing facility in New Jersey, which you can see behind me. So everything I do on a daily basis is usually involving 3D printing. I am joined today by Brelan Blake, who's also an application engineer for DesignPoint. Hey, Brelan, how you doing?
Pretty good. How you doing today, Andrew?
I'm doing really well. Brelan is a SOLIDWORKS expert. He's got a lot of experience with this. So basically what we're doing today is I have an issue with a part that I would like to 3D print, and I was hoping Brelan could help me out with that. What do you say, Brelan? You gonna help me out today?
Absolutely, that sounds great.
Sweet, man, appreciate it. So here's what's going on. I've got this really cool part that was designed to show off a lot of features that you can do really well in a Markforged printer. So it's got all these different features, and we can go over that a little bit later. But one of them is in the center of the part, there's an embedded nut. So the way this works is you pause the printer, and then when it pauses, you actually physically walk up, you put a nut into the part, hit resume, and then it prints right over the top of the nut, thereby embedding it and creating a really nice threaded insert. So you don't have to 3D print the threads. You can have off-the-shelf hardware creating that for you.
That's awesome.
So it's great. It's a hybrid part, which is really cool. So my issue is that in the center, the cavity that I've designed to hold that nut, the position isn't right. It's aligned with a roof layer, and that has potential to cause issues. So basically, without getting too much into the weeds, I want to adjust that cavity inside the part. So yeah, I think the first thing we should do is probably take a look at it in SOLIDWORKS, and you can show me how to make that adjustment. What do you say?
Sure. That sounds great. Why don't we jump into the 3D environment here, and let's open up that part in SOLIDWORKS. Take a look, okay?
Awesome. Sounds good.
Great. Okay, so we're in our 3D SOLIDWORKS environment here, and now we're going to look at the part that Andrew has kindly sent over to us, and we're going to look at his center cavity, where the hex nut is going to be inserted into the 3D print for this part. Okay, so we have the print open now. We're going to do a sliced section view here, just so we can look inside. And to refer to what Andrew was talking about is his nut here, as you're going to insert it in the part, pause the part to insert the nut here. The top of the nut surface is parallel to the sides, and he'd like to decrease the nut cutout just a little bit here to increase some more material on the top, and also to alleviate this top here from possibly coming off as a weak point. So let's go in here and take a look. What we're going to do is we're going to adjust some of our geometry here. So we'll look, we have the cut is set on our plane 5. So we're going to go ahead and edit that feature, and we are about 1.5 millimeters. So the actual sketch is starting at the bottom of the nut and going up. So we're just going to reduce some of this here. Type in 1 millimeter just to decrease that. We'll decrease the way that the nut is cut into the part and lower it down. Okay. Now that we can see that now our cut is a little bit below our surface here, and we still have some material wall on the bottom of our nut as well, with an increased wall thickness on the top. So we'll see how Andrew likes that. See that he's nodding his head, and we'll go ahead and take a look and see how this part comes out.
Okay, so now we have taken the part and loaded it into Eiger. Eiger is a proprietary software created by Markforged for Markforged. And what this allows you to do is add reinforcing fiber, continuous fiber into your part in order to greatly increase the strength, or depending on what fiber you put in, possibly durability or heat resistance. But in this instance, we're using carbon fiber for strength. So first thing you do is upload your STL file into the software, which I've done already, and this is what you get. You see metrics on the left, which is pretty cool, how long it takes to print the part, material cost, all that. It's giving me one little warning here. It's saying that turning supports on is recommended, but for this part, and really to print great threads, you want to try to strategize to turn supports off for the sake of the thread. So.
Okay, so you don't think you'll need any supports on this part?
No, so the only area where it would actually need supports is in that center cavity where the nut is going to go. But since we're going to be putting that nut in there, the nut will be the actual support. So other than that area, you don't need it. And these little lettered areas would be maybe the second area you'd think about, but they're so shallow that you can get away with not using supports, and the lettering comes out great there.
Great. I'm excited. This is going to look great.
Yes, wait till you see. This is the fun part coming up right here. So to add continuous fiber to the part, you're going to go up to the top right here, and under reinforcement material, you select carbon fiber. Okay. So now when you do that, this reinforcement tab pops up. And although I could probably do a couple settings here, I'm going to just go ahead and hit save, because there's an internal view. And when we go into the internal view, it'll be a lot easier to manipulate the fiber. So I'm going to show you guys that way instead.
Okay, great. So, and not every 3D printer, of course, can print carbon fiber, right, Andrew? Just the Markforged.
That is correct. There's a lot of printers that print chopped carbon fiber. So what they do is they chop up a bunch of carbon fiber, and they blend it together with a plastic, like a nylon or something like that, and they create a carbon-filled nylon. And that's actually what Markforged does too. They have what's called onyx, that's their base material. But then to add the continuous fiber is a patented process by Markforged. So that nobody else can do the way that Markforged does it. So now we've gone ahead and saved it. It took a second because it's actually, the version that we have is cloud software. So it takes a minute to slice there. Go into the internal view.
I'm getting ready. This is going to be great.
So now it gives you this really neat X-ray of the part. And the gray area that you can see through is the regular plastic, where the blue is the continuous carbon fiber that we just put in there. So on the bottom here, this bar across the bottom basically represents the part. The left side is layer 0, the right side is layer maximum. And these two little bars of blue in here are where it has attempted to put carbon fiber into the part, where it looks like the bottom was successful and the top, for whatever reason, the geometry was probably too thin up here. But this is kind of the default setting. If you do nothing, it does what's called adding sandwich panels. So to put a little on the top, a little on the bottom, because it thinks that that's a good way to go, just to increase resistance to bending a little bit. And a lot of times it is. But for this part, I really just want to put some carbon fiber around the bottom. I'm just looking for a little bit of stiffness here. So the first thing I'm going to do is go to this top right one. I'm going to click on this. Oops. Sorry. Not wanting to click on the entire bar. Try clicking away, back. Well, let's see if we can do this a different way. So we're going to click on that, turn the fiber off, hit create group, and most of our fibers should go away. It looks like I might have missed a little splotch there. But honestly, there's no fiber in the top anyway, so I don't even really care about that one. I was just doing it for completeness. But let's go to the bottom one now. And basically what I want to do here is just increase this. So I'm going to grab this little arrow here. I'm going to increase the area where the fiber is. So you'll see it now build from the bottom where it was up to the area where we just set it.
Okay, great. And Andrew, these results are pretty accurate. Is that right?
Yeah, for Markforged, these printers are great. Yeah, they're known for their accuracy and surface finish to get parts that look really great, but have, you know, tolerances that are making the parts functional for, you know, real work, end use parts, you know, tooling and fixturing and gears and replacement parts.
Wow.
And that's really why you add this carbon fiber, to give you the amount of strength you need to do those kind of things.
Right. That's really where the accuracy comes into play here with the Markforged parts. This is great.
So yeah, it's a little slow right now. Typically it's faster, but when I'm sharing a screen like this, it tends to slow the computer down a little bit. So
sure.
Apologize for the wait here, but when you're sharing, this is just how it is.
It's some of the magic of working virtual.
Exactly. But yeah, so once we have this loaded in what's called the 3D mode, we can actually switch to a 2D mode, where then you can specifically see where the fiber is and how exactly the software is laying it in. So I think we'll do that next after this. And then after that, I can show you actually one of the parts. So we can actually look at some of these features that we're talking about.
Okay.
But yeah, as the part saves, it's going to update these metrics on the left. So you always know how much print time you're using, you know how much material, difference between the carbon fiber and the regular plastic. So it's pretty neat. It's very intuitive software, it just kind of works.
Great.
What do you think, Brelan? When are you going to get one of these in your room at home there?
I don't know. Hopefully, from a good boy this year. Hopefully, Santa will place one of these under the tree. We should work like that.
Wow, if your Santa's dropping off $20,000 Mark IIs, I gotta get on that. So then once you actually once it's added the fiber, I went ahead and hit save, and it's just going to take another moment for the software to actually now save the change that we made.
Do we want to jump ahead and there it goes.
Yeah, it should just take a moment here. Okay, so now what I wanted to show you guys is the 2D mode. So in the 2D mode, you go layer by layer, and it shows the actual tool path of the nozzle. This is exactly what the printer is going to do. And when we get up to the layers that have the carbon fiber, now you can see the blue lines are the carbon fiber. So there is what we call concentric fiber going around the outer perimeter, and then isotropic fiber in the middle, which is kind of filling in between the concentric rings. And as you click through, so this is layer 6, layer 7, layer 8, layer 9, you can see that it creates a cross-hatching with the fiber. So if you have a load in the Z direction, coming straight from the top, that cross-hatching creates resistance in that direction. So it's a good strategy to use to resist bending, like a Z bending force.
Right, which makes a much stronger part, correct?
That's absolutely right. I mean, with the carbon fiber, you can get strength that's up to about the strength of 6061 aluminum. So it's actually, you're printing a composite that's actually metal strength. And that's really the difference with this technology.
Wow, that's remarkable.
But now that I've added that fiber, and there's different stuff you could do. You could go in here and play with this pattern and add rings, reduce them, or change angles and stuff. But for this part, this is okay, because this is just going to be a showpiece. So I'm pretty happy just having that fiber the way it is on the bottom there. So that's all I'm going to do there. And then to print the part, you hit this print button on the lower right. And now the part is going to show up on your print bed.
Okay.
Again, usually this is faster, but the lag here, there we go. Now, when you're at this stage, you can manipulate your part as far as how you want it to be on the print bed. So with this part, I'm going to be embedding a nut in the center, so I'm probably going to move it all the way to the front just so I have really easy access, but it doesn't really matter. You can actually remove the print bed to do the embedding of the nut if you want, but you can actually turn the part as well if you want to type in angles here. And you could add other parts. I wouldn't have to just print this part. We could be printing, you know, a number of parts here.
Sure.
But you basically add the part here, and then you hit print, and off you go.
All right, great. This is gonna be exciting.
Okay, so here's the part. Now we've actually
great.
printed the part, and I'm going to show you guys some of the features here. So on this arm here, we've got OD threads. These were printed without support material in there, and they come out great, just according to the specs of the CAD model. Did not need to adjust anything.
And you could actually screw that right on there. No post-processing
screws on,
involved.
nice and tight. Good clearance on that. You know, it works really well.
Wow, that's really nice. That's great quality.
We've got so that's an OD thread, of course. We've got some ID threads on this other arm. So kind of a similar story there. You can, you know, screw your bolts or your nuts on.
Oh, great. That's awesome. So Andrew, did you have to do any post-processing to this part to get the part clean enough to actually use a nut or bolt to screw into these threads?
No, there was actually no post-processing.
Wow.
The only thing you have to do to a part off a Markforged printer is remove the supports. This part doesn't have any, so I didn't have any supports to remove. And also you apply a thin layer of glue to the bed to get it prepared. So when this comes off, you might want to run a little water on the bottom if you care. Otherwise, you know, it's just a little sticky, but
sure.
You really don't have to, there's no major post-processing steps like you have with SLA printing or something like that, where you'd have to put it in a vat of chemicals and soak it. You know, this basically just pops right off the print bed, and it's completed.
Sure, that looks great. That part really looks good.
Yeah, this is one of my favorites, actually. This is a really cool one. And then in the center here, this is where we made the change. So we lowered the position of the cavity of the nut so it doesn't align with this area here, the roof. You know, we're having an instance where this could pop off. So now there's more material on top, making it stronger, and the alignment is not, you know, set to be aligned with this area here, creating like a cap-like feature. So,
sure. So that added more material to the top surface of the nut.
Correct. So basically, we moved the nut down, and now there's more material on top, making it a little bit stronger. And there's actually some lettering on the side of the part, which is a little bit hard to see. But actually, I have another version that I did, which has some dry paint in it.
Oh, that looks great.
By adding that dry paint, you can see lettering really nicely. So sometimes I use that. It's actually stuff that's made for bowling balls, believe it or not.
Okay.
The lettering on bowling balls, it's like a wax. They call it a dry paint, and it works really good to fill in lettering on 3D printed parts.
That's great. That looks really good. That part looks really clean.
Yeah, and then this arm, kind of the last thing to show you is a heat set insert. So these are pretty neat. If you decide you need a finer thread than a 3D printed thread, you can order these off McMaster-Carr. They tell you exactly how big to make the hole in your CAD model. And basically you heat the guy up with a soldering iron, and you just push it down into there. And then when it solidifies and hardens, it actually creates a really nice seal between the knurled edges of the insert and the hole. So it makes for a nice insert there. Okay,
great. Great. That looks really good.
Yeah, that's about it. I mean, we've got some more writing on some of the other sides. I mean, we did put some carbon fiber in the bottom here, so this is actually unbreakable by hand. Oh, and I know you can't really tell, but I'm actually trying to break it. I'm actually getting some really good torque there, and it doesn't move. So
that's
mission accomplished.
That's fantastic. Well, thank you, Andrew. That's really incredible how strong and how clean and detailed a part like that is. It really looks great. Those changes really came out really nice.
Yes, it was my pleasure sharing this with you, and thank you so much for helping me with that issue.
Sure, absolutely. Thanks for involving me on the project.
You got it.
All right.
All right. Thanks so
Thank
much,
you.
Brelan. Have a great one.
You too. Bye-bye, guys.
Bye, everyone. Thanks for joining us.